The talk that you're in right now is the instrumenting point of sale malware talk. This talk has a little bit of a dual purpose to it. Half of it's about how we're going to be how we intend to propose to communicate malware analysis more effectively. So how can we publish our information that we've found about malware in such a way that another analyst can pick it up and run with it and not waste time spinning their wheels doing the same old shit that we did. And so that's kind of boring, and it's a preaching to the choir type of thing, because of course you're like, well, of course I want malware analysis to have more detail and things like that. So to make it a little bit more fun, we have a case study in here, and it's the Jack POS point of sale malware. And on your DEF CON DVD, there is not a sample for it because I didn't want to have something triggering antivirus on the DVD, but available on VirusShare right now. There is a sample, and the hash is on there and everything on the white paper and all. So you'll be able to get a hold of that as well. But what I do have on the DVD is a copy of the actual command and control server for that piece of malware. Not a recreated one like I have my students do or anything. It's the one that the bad guy actually uses and sells. So you got a real value with it. It's probably worth about as much as you paid for the badge. And I'll show you how to set it up. So I'm Wesley McGrew. I'm assistant research professor at Mississippi State University in the newly formed Distributed Analytics and Security Institute. For me, for my research, I'm sort of the pragmatic and unapologetic offensive security guy. People talk about how you should be well balanced on offense and defense. I think that there's enough stuff out there to break and enough unique ways to do it, and it's hard enough to do that you can spend all of your time breaking things and productive with that, and then just hand it off to whoever likes defense to actually fix that. So my research largely centers around breaking things, reverse engineering things. I teach at Mississippi State University. I teach a cybersecurity class and a reverse engineering course, and that's part of our Center of Academic Excellence designation from the NSA in cyber operations. And this is my 4th year speaking at DEF CON. I freaking love speaking here, so I always try to come up with something special for it. My first year I talked about I talk about a wide variety of things too, as you can see. I pulled the title slides down here. I've got post-exploitation, forensics with Metasploit. I've got SCADA HMI vulnerabilities compared to the vulnerabilities in Microsoft Bob from the early 90s. And then last year I gave a talk on analyzing and counterattacking attacker-implanted devices, essentially attacking penetration testers, attacking penetration testing software, attacking penetration testing devices. The case study that last year was the Pwn plug from Pony Express, and I dropped a little 0-day on that there. And I gave a little bit of a warning last year that, there's lots of these devices, and there's like these Wi-Fi pineapples around here that you might have heard about getting hacked here at this conference. Well, having given that talk last year, I've had people come up to me and say, hey, are you in any way involved with these hacks, these compromises of these devices? And I find these accusations to be outrageous. I find these accusations to be fantastic. And to tell you the truth, I hunt pineapples. So if I manage to pop yours over the past day or two, that's the SSH password. I would actually just recommend a reflash. I do some really dirty things to it. I didn't have one of them while I was developing the exploit, so the payload's just kind of like, YOLO, let's just get rid of this stuff. So yeah, my bad. All right. Now back to the first slide. Back to what I'm really talking about. So the point of sale malware. The purpose of this talk is to promote better communication in malware analysis, so that we're not wasting time, so that we're sharing information We don't have analysts reinventing the wheel every time. So the idea is to adopt better practices in describing and demonstrating malware capabilities. We want to show how these things actually work. We want to, a list of indicators of compromise is nice if you're on the defense side solely and you just want to see, is this on my system? If so, don't let it on my system. If so, get it off. But if you're investigating, what's the scheme? What's the plan for the attacker? What are they going after? How are they doing it? What's their operation like? You need a little bit more in-depth analysis of this stuff. So the idea is to supplement written analysis, like we see now, with illustration that uses the malware itself. So if we have, this piece of code. We can say, oh, well, it has this particular domain name generation algorithm. It has this particular memory scraper in it and everything. But it's nicer if we can, as the malware is running, show what it's doing. I mean, these things don't have user interfaces when they're running. They don't want to pop anything up on the screen. But what we're going to show you today is how to, as you're developing your malware analysis, build a harness to illustrate what you've found so far. And we're going to show this off. And so the idea here is this is part of the scientific method. We want, or at least the important bits of it, the most important bit of it is that people can reproduce your work and verify your work. So there's a lot of analysis of the big name, high profile malware that companies are putting out their white papers on it. And there's, for many different reasons, there's some of them are hard to replicate. Sometimes there's hidden information. Sometimes they neglect to mention important aspects of it, like how the hell they unpack it in the first place. Things like that. So the idea is we want to have a situation where people can verify our results, start new analysis where the old analysis left off. And for me, the big thing is educating new reverse engineering specialists. I teach a course on this. And so being able to pick up where somebody left off on some advanced persistent threat malware, being able to pick up where someone left off on that is huge for them because it gets them deep into the malware, it gets them to looking at important stuff, and they're not just starting from scratch every time. And so the issue here, though, is most malware analysis that's published is targeting indicator of compromise consumers, people who are building, endpoint protection systems or managing those systems, firewalls, gateways, and things like that are scanning things, looking for these indicators. That's the bad thing. Don't let it on the system. But there's those of us who are interested in the inner workings of it that this is really important for. So what's missing in a lot of malware analysis out there, and I'm not going to, start going down the list of Mandy and Norman and all these folks and everything publishing white papers on malware and pointing out exactly what's missing in each case. And I'm going to talk a little bit about why they don't have some of that information. But this is what's often missing, that are key aspects of the analysis that keeps us from being able to use it at a very deep reverse engineering level. The biggest one is just information on the hashes or information on the sample. Sometimes you don't even get a hash of the malware. If you do, then you go off searching for it in public domain, open source sources, and you can't find it. It's something that they've pulled off of a client system, and they haven't submitted it to VirusTotal, obviously. They haven't given it to the VirusShare folks, and it's just not out there. And so, I've run into this before. A sample I want to take a look at, it has published analysis out there. You just can't get your hands on it. And I wind up finding, some shady back channel connection to somebody who's on a mailing list with somebody else, and I don't tell anybody I gave you this sort of thing. And that's silly to have to do that for code that an attacker wrote. It's not like we're protecting intellectual property here, right? So the availability of malware is often missing, and again, there's reasons why that happens, and we'll talk about those. As far as procedures concerned, sometimes steps are skipped. I mean, obviously steps are going to be skipped, especially considering the target audience for many of these things. Things like how did we unpack it, and how did we find this functionality. Things that it may have in common with other malware that we just didn't bother looking at because we weren't interested in that part of it. So sometimes part of the process that somebody uses to do this isn't documented well. You know, as computer geeks, we're not very good about keeping lab notebooks about what we're doing, so we just kind of hack at it for a while and then we come back and document it later. That's a problem. There's often context missing. You know, so there's, especially if there's no sample available, then there's also the ability to redact things like what hosts are being contacted, what are the command and control hosts, even what industry was this malware found in, you know, because that's important. And at the very lowest level, just sort of the internal points of reference. Things like just addresses of where, like what functions are what, you know. If you went through all the trouble of reverse engineering, you know, this huge chunk of the functionality of malware, then what's the harm in giving me, you know, the function names at least and the arguments that you figured out? And a lot of that's missing. The devil's advocate viewpoint of this is that it's missing because you know, number one is, you know, the target audience of the white paper itself. It's for people who are working at it at a higher level than we want to. I'm assuming everybody in here wants to get down and dirty with malware, x86 assembly, really mess it up at that low level. And you know, if you're down there, you're going to be pretty disappointed with a lot of this stuff. So we're kind of left to pick through for technically useful information. I'm always like, you know, different algorithms for unblurring things and unpixelating things and anything to try to figure out that IP address behind the redaction and anything. You know, that's me. That's what I'm always trying to do. There's a lot of added effort in documenting things well. It takes more time to reverse engineer something if you're keeping a lab notebook and documenting what you're doing. Because usually we're flying through IDAPRO, naming this, naming that, cross references. 5 minutes later we're in another part of the code and we couldn't tell you how we got there. But if you take a little bit more methodical approach, then it's easier to sort of keep track of all that and you wind up with a really good paper at the end, but it takes a lot more work. You know, again, with the target audience of these papers, there's a concern for analysis consumer safety, the consumers of the analysis. You know, you don't want to give too much information so that they, you know, grab the sample and start playing with it and infect themselves. That's a little bit silly, you know. If you have to put some boilerplate disclaimer in there, go for it, whatever. The most compelling argument for this, for me though, the devil's advocate argument that I like the most and I can get on board with is client confidentiality. Sometimes you pull this malware from a system that's a client of yours and you don't know yet if that malware is specifically targeted against your client. Perhaps it's hard-coded with internal information that they've previously found out about your client. You don't want to upload that to virus share yet. You don't want to upload that. You don't want to upload it to virus total yet, but a lot of y'all do. You know, so I can understand that. But once you sort of kind of get into reverse engineering and you find out that, hey, this really isn't that target, it doesn't have, you know, specific information about my client in it, then it's time to start thinking about, let's push this out to where other people can take a look at it. The biggest reason, so all those other reasons are the reasons that if you approached somebody with this, they would try to claim. The last reason is the real reason in many cases, and it's competitive advantage. There's so many people doing these analyses. There's so much you know, benefit to them for being the first out there, to being the best out there, to being the most accurate out there. Maybe not the most accurate, but to have that public image as being the ones that reverse engineer the next Stuxnet or something like that. So it's not in their best interests to share that with anybody. They don't want to. If you had all these big companies, you know, splitting up the work, you know, you'd have it reverse engineered in a snap. But that's not how they work. That's not, and it's a competitive advantage, and I get it. You know what? I hold the contents of my talks and anything very close to chest and anything to represent them because, you know, that gives me an advantage. But that's the real reason, rather than any kind of, you know, altruism. So what's being done elsewhere? Elsewhere in science. So reproducibility and verifiability are big in academia, in any scientific endeavor. Peer review is supposed to enforce this. If you get published, you're supposed to, that work is supposed to have been peer reviewed and able for anybody to take that work and replicate it and verify those results. That being said, we may not be as rigorous as that as we ought to be with computer science and computer engineering. But it's something to shoot for, at least. It's something we strive for. You know, you want to have a software environment, data, all that documented to the point that somebody can recreate the experiment. That's the gold standard for any kind of science, computer or not. And recently there's a push for having research papers that embody the algorithms, like, especially in computer science and any kind of like algorithm type, numeric computation type situation. There's a push for having papers that embody the algorithms and data within the paper such that you can manipulate them interactively. And so there's been challenges out there to implement systems for this. And so you have a paper with embedded algorithms and data. Now, for somebody who attacks things like me, I'm thinking attack surface just went crazy on this thing. But assuming we can do this, and we run PDF renderers anyways, and so they're kind of nasty anyways. So why not do this? It sounds a little bit scary regarding malware, but if we're all professionals and we're all taking on this challenge of reverse engineering malware, maybe we kind of put on our big boy pants and deal with it. So the recommendation here is to go beyond just normal sandbox output for malware analysis. So that's one way of sharing a malware analysis, but that's all automated. And it's all one size fits all. It drops it onto a clean Windows system, it runs it, may click a few times to trigger whatever, and then it logs all the interactions of the systems. The problem with that is that's very surface level. It may not be giving the target, the malware, exactly what it's looking for in order to do its thing. For the point-of-sale malware, it may be that it's not. Giving it processes that have credit cards in memory, so it doesn't exercise a large part of its functionality. We want to document these host environments in such a way that people can reproduce them or host them in a cloud environment where they can access the same environment or a copy of that environment. We want to give target data, something to exfiltrate. So we start giving this thing what it wants, and that's target data, network environment, all this sort of thing. Give it what it wants to talk to. And in this case study, I have the point-of-sale malware's command and control server, but that's not very common. We don't always get the command and control server for the malware. Why not write a bare bones one? One of the exercises in the class that I teach in reverse engineering, they take some of that at Mandiant APT1 malware, they give them to them as a binary blob, they figure out how that thing talks to a command and control server, and they implement a working command and control server for it that lets them control it. And it's a very great exercise for them. And if they can do it, 4 or 5 weeks into reverse engineering training in a university environment, why can't anybody else? So give it that sort of that other thing to talk to. And the other thing, besides just giving it what it wants, instrumenting this thing so that we can watch it run. So it's not just running in the background unseen. And so the coolest tool for this I know of is to write your own debugger for it, and it's easier than you think. WinApp Debug is a great library for doing this. Again, I use this in the classes and anything. I think it's cheating for my students to use dynamic analysis too much. I like for them to kind of sit there staring at assembly for a good chunk of their time. But if they're going to do some debugging, I like for them to write their own debugger. So that's a great library for kind of bootstrapping yourself up into it. It allows you to isolate functionality in the malware, lets it run live, but when it hits something that's interesting, show us what's going on. And you could have a good visualization of this, or you could do a crappy one like I did. So the case study here, so that's all, preaching to the choir type stuff. I don't think I'd get any arguments. It's like, we need to communicate better, of course. But the case study, this is the fun part, huh? So I'm having an acknowledgement slides right here in the middle of my talk, because I want to make sure I get into these before we geek out on the demo. The original malware samples for this are sourced from Xylitol, I guess that's how I'd pronounce that. Great guy, runs cybercrimetracker.net, and basically it's a live feed of kind of shady-ass sites that have things like this. So you can grab some fun things off of there and kind of play around with them. I actually got turned on to this particular sample through a tweet that I've long since forgot who tweeted it, who had a screenshot of the command and control server's web interface up and had redacted out the IP address poorly. They left, you know, they left like the top couple of rows of pixels left there and everything. I was like, well, here we go. About 5 or 6 different possibilities. Let's do this. And so that's kind of how I got turned on to it. But an official source, cybercrimetracker.net. You know, there's been a couple other analyses of this same malware that I want to acknowledge. These were published after I had done my analysis, but I didn't want to publish my analysis until I got here so I could drop some cool stuff on y'all. But to give them their due credit, of course, the Spider Labs guys had a great analysis. Jack POS, the house always wins. You know, a couple of things different from mine, and I'm not sure. I don't remember if it was a different sample or if they just didn't look at it the same way that I did. And then the Malware Must Die folks had a look at it from the viewpoint of tracking down the author, and they had like a forum post that they had found where the guy was selling this thing. Now it's free on the DEF CON DVD. Cool. So I've got more citations in the white paper for tools, executable paper, prior work. I believe in giving a white paper out with these talks, and I highly encourage everybody to do so. Nothing angers me more when there's like one good source, one good talk for a particular subject, and you go there and you're downloading slides and no white paper. And so I'm left to kind of guess as to what they were talking about in there and kind of fill in the details. So why Jack POS? Well, it's the one that fell into my lap whenever it was time for DEF CON CSP to roll around to a certain extent. It also sort of fell into my lap around the same time. I've got 5-month-old twins right now, and so I was analyzing this just around the time they were born and everything. So when I was unable to sleep and I wasn't holding one of them, or if I was just holding one and I could work with the other arm, this was what I was tinkering with. But it's kind of a cool one to look at for this because there's a lot of POS malware, huge topic right now. It's probably what y'all lined up out there for. You didn't know you were going to come to the I Hunt Pineapples talk, but you know, it's a big thing this year. So yeah, chase that buzz. The C2, the command and control server was available. So I have the ability here to demonstrate the complete environment for you. I managed to take that from the server that was listed. So I can show it to you from card swipe to command and control. It's weird at a low level because it looks like it's using C++ strings and everything. It basically dynamically allocates all the memory for strings at the beginning of the program and only uses those offsets, those memory locations for the strings later on. So your cross references and IDAPRO are all broken. But at runtime, doing it dynamic, it works out pretty good with these harnesses. And the harnesses that I have separate a separate harness for the memory search functionality. It actually hooks into the function that does the sort of regular expression search for the credit card numbers. It sets up the stack to call it and just calls that function. So there's a harness that just runs that part of the malware, and that's a cool way of cool use case for this. Is I just want to look at the domain name generation algorithm. I just want to look at the scraper. I just want to look at this part of it and anything. Let's rig up an environment where we can just continuously run it and reset the stack back around and call it again. For the harnesses, WinApp Python scriptable debugging. It's a really fun library. It's very well documented. There's lots of examples. If my students can do it, anybody can do it, right? You know, you just set a bunch of breakpoints. I set them all up in a dictionary, and I have a loop that just goes through and sets them all up. You get callbacks to your Python code whenever they trigger. And then it's just like old school Commodore 64 programming. You just peek and poke in memory. It's great. You know, you can get the current state of the thread, current state of the process. You can read and write memory, mess around with the stack, and then keep going. And so it's pretty cool like that. So I can I can do some pretty interesting stuff that I'll show you on that. That's the SHA1 for the sample that I looked at. There were several on that same server. It was apparently the server for the person who actually wrote the malware, not a customer of it, because some of the samples were hard-coded to 192.168 IP addresses for command and control. So it's basically the samples he was using to test it locally. So I think I've got a list of the other SHA1s for like the internal testing samples and things like that in the white paper. If not, you can contact me. I can get those to you. VirusShare.com. If you're not familiar with it, go on there, or either get an invite from me or just request access to it. If you're an antivirus researcher of any sort, even amateur, they're pretty cool. You can get on there and download lots of samples. Everybody's uploading to that now. And I'll also put the sample up on McGrewSecurity.com if it becomes a problem to get a hold of it. That's the only part that's not on the DVD, of course. The command and control server is on the DVD. It's PHP web application. It's using this weird model view controller framework called Yi. I'm a Django person, Python, anything, so this was a very big change for me, trying to understand what this code was doing. It's a little tricky to set up. I'm not going to go through all the steps of setting up like a Ubuntu server and anything to get it up and running, but all those steps are in the white paper. This is a view of the panel, and we're going to go through this interactively, but there's a data model. You got the model view controller type interface for this thing. And so you have objects in there, tables of them. So bots, cards, commands, track dumps. There's ranges of IP addresses for the geolocation that I didn't manage to get because I didn't grab the SQL tables at the time. Track data, users for the system. It's actually in a state of development, it looks like. If you start digging into the source code of this thing, it's the way it stands right now. You log into it, and you're basically the only user. There's not any kind of separation for different users, so you might as well only have one user on the system. But it looked like there's a lot of underlying code there that kind of indicates that instead of selling, selling generated samples and the code for a command and control server, that he would migrate to having this as a service where he would set it up and have client logins for people who want, dumps of credit cards and things like that, and allow them to get small subsets of the data set. And it looks like that's what he was working towards, but there's indications of it, but it's not completely implemented. It's all pretty much, one user gets everything type of thing. Back to the sample itself. It's a UPX packed sample, so thank God I'm not going to go into like a weird unpacking talk or tutorial here. I'm just happy when it's done with. So the nice thing is you can just UPX extract this thing and you're good to go. But the unpacked version, for whatever reason, maybe I'm using the wrong version of UPX or something, it crashes at a check for a stat cookie in one of the earliest functions. And I think, I know that it's just not rebuilding the relocation tables correctly. The fix for this one would either be to figure out exactly what UPX to extract this back out with, or what alternate packer implementing UPX it was. But the easiest way to do this is just to disable ASLR for that particular binary. And in your PE headers, you can go to image NT headers, optional header, DLL characteristics, dynamic base, unset that bit, and now all of a sudden your malware doesn't hop addresses every time you run it. And I like doing this if I know that a sample is not going to freak out if I do this. I like doing this anyways because that means I don't have to keep rebasing in my static analysis in IDAPRO to keep all my addresses consistent. It also makes the harness design a little bit easier. This is the nasty main loop of the program. Up towards the top, it calls a function that sets up all the strings that are going to be used in the program for the rest of its execution. And that's the command and control server, the file names of the executables that it tries to install itself to, and also process names that it wants to avoid whenever it's doing its grepping through memory for credit cards. Towards the bottom, down that red channel there, you know, in IDAPRO, you've got when you have a jump, you know, if it's true, then you take the green path. If it's false, you take the red path. So the red path there is essentially after a check for am I installed or not, and it dumps down to some code down there at the bottom that installs itself. So it copies itself in, it does some very standard registry persistence, sets itself up in run keys and things like that. The harness that I designed, it patches the command and control string as it's set up so that it points to one of my VMs. And so that's something you'll want to change for your environment. It patches the installation check so that you can just run it from a directory and you don't have to dig it back out of one of the app data folders in the middle of it. And it also it prevents this watchdog process from executing. It spawns off another process that watches this process, and if it dies, it starts up another one. And that is really obnoxious when you're trying to keep this thing kind of under control. You want it to stop when you tell it to stop. The other stuff that it does is it presents anything from shell executing. There's some functionality to install other malware through this malware. And I just like, let me know what you were going to run, but don't quite do it yet. Communication-wise, there's a loop up there where it looks for the command and control server. It hits a post echo address on the command and control server. If that server responds with simply up, no HTTP, no HTML, or no HTML tags or anything. If it just says up, then it's like, okay, I'm talking to the right command and control server. I'm going to keep going on. That's where your sandbox would be like, so that keeps normal, simple sandboxes from really getting much from this. Once it figures out there's an actual command and control server, it checks its own state to see if it has already snagged any track data from memory. It does it later in the loop, but it does come back to here. So if it got earlier track data, then it's going to base64 encode that out and send it out. And so we can set up our harness to display that and not base64, so we can actually read it. And it checks a queue. They're actually clever. They have a queue on the command and control server of commands to execute on the target system that are being distributed out to the different bots. The hosts uniquely identify themselves via MAC address. And there's probably some weird cross-site scripting, cross-site request forgery type stuff you can do with that. Commands-wise, you've got so there's very limited set of commands in this malware. You know, there's some of them are backdoors, and it's kind of general purpose. Let's mess around on the system and set up things and look for files and stuff like that. There's not much of that on here because it's scraping track data and it just does that. You don't have to tell it to do that. It's always doing that. So the remainder of the command set's very simple. Kill just knocks the bot out. I think it even uninstalls it. There's an update that replaces the current malware with the latest version of it that's in a directory on the command and control server by hitting the post download function on the server. And then aside from that, there's an exec that's basically, it looked like on the server that I pulled it from was being used to install other malware, because if you got a botnet if you got a botnet, you can make some good money installing other pieces of malware for other folks, and so that's a way of doing that. There's a memory scraper in here, and this is the memory scraper function that you're seeing here. In the advertisements for this particular piece of malware, he's like, does not use regular expressions. Well, this code essentially does the same thing as a regular expression. It's an embodiment in code of a regular expression search for valid credit card numbers. The reason why he's bragging about it not using regular expressions is otherwise any idiot can just run strings on a binary that actually is using a regular expression library and see, hey, this thing's including some GNU regular expression library, and here's the regular expression string that it's compiling down to use for it. And so it's a little less subtle. They're having fun over there. What's going on? And so it does some interesting things. It gets a list of processes. I say functions there, but processes. It avoids 64-bit processes. Because it's for whatever reason, I guess it just doesn't figure there's going to be anything there. and then it has an internal table of processes that it knows is not going to have track data. Windows system processes. Basically, if you did a PS list on a stock Windows system not running anything, it's avoiding all those because that's not point of sale software. It iterates and searches through two regular expression ESC functions that implement the ISO IEC standard for card data, and it's more or less adhering to the standard. It's sort of with all the little quirks and everything for getting, Visas and MasterCards and things like that. And so it was an iterative process harnessing this particular function and just throwing what I thought were valid cards at it until I was getting traction, getting through, and getting more code coverage through this. The harness basically identifies the search process in both harnesses that I demonstrate. And then one of the harnesses will basically let me point this function at an arbitrary process ID on the system for testing. And so I don't have to just sit there scanning the entirety of memory every time. All right, so the demo that we're going to show off here, the samples MD5, that's the MD5 of it. The other was SHA. I was like, that doesn't look familiar. I'm looking at two different samples. No, it's the same sample. The two harnesses, one instruments is all operation of the thing. The other one that I'll probably just show you the code for just skips to the proc harness. I can demonstrate that. We got a lot of time. I've got a track generator. Basically, it's just a Python script. It generates a bunch of valid-looking tracks and just sits there on them in variables in memory, and this thing will come around and find them. And then the PHP source for the actual command and control server. Again, due to issues of getting this command and control server, I did not get the database schema, and unlike Django, you can't just generate a schema from the model. I don't know. And so I recreated it, and it works. There's some stuff that's probably not quite right, but it works well enough for us. So we'll bump out and go into VM land here. All right, so we've got, a Ubuntu server here configured up with this particular point of sale malware. I have forgotten the login password for this thing twice already. Once a week ago when I went to look at this, and then once again earlier today, like around lunch when I was testing these, I was like, I can't remember the password for this thing, so I wound up resetting the password for the Ubuntu, and for the actual web interface, I just went in and knocked out the hashing algorithm. So basically, to log into this thing, bad guy at localhost, password, who knows, and then my own dang system has a CAPTCHA. And it's the worst CAPTCHA ever. It's the same font every time. Verification. What? What? Is that an I? All right, cool. Oh, yeah. And that was a successful demo. So we've got, in the low resolution, we're kind of looking at this kind of nasty. Zoom out a little bit, and that's the way you normally see it. And you get some statistics for things that you've seen. This is a reverted VM, so we're not seeing anything yet. You've got a list where the dumps will go, where the bots will check into, and the only settings right now are account password, and this is where you would have like a user with admin rights, and he'd be able to add other users and things like that. But that's not implemented yet in this one. Maybe I need to steal another C2 from him. All right, so on the other side of this coin, we've got the client for it over here. Oops, let's pull up. We have in here. So we've got three Python. We have the malware itself currently named something such that it's happy with it. It tries to pretend that it's a Java update scheduler. That's its default. It has a whole list of them. If it can't pull one, it does another one. We've got the main harness. We've got the search process harness. What I'm going to do first, though, is show you the code to generate the track data, and just kind of implementing the base algorithm for it, just John Doe and the various elements of that particular ISO standard, and some probably pretty terrible things. I never did ACM programming contests or anything like that, y'all. So we're going to run that in one window here, and that is going to generate, I can mute that now that Iron Man's over. Python, gen track data. And so that generates a bunch of track data and just kind of sits there on it. It's in a Python dictionary, and it's just sitting, or a Python list, and it's just sitting there in memory. So we can just leave that there. We can run, hopefully Procmon's on here, Process Explorer rather. Do I not have Process Explorer on here? Because we can actually watch this a little bit nicer. There we are. You're hiding over here. So right now, this PID 1480 is the one for that particular track data. We'll show off the search process harness first, since we've got that PID fresh in our memory. So our search process harness, and it's actually our simplest one. Basically, I've got some neat stuff up here for just colorizing my log output and everything, but the gist of it here is I set up a list of breakpoints here and callbacks for them. I have some stuff that actually goes and sets those, and basically anytime one of these hits, one of these functions up here gets called, and so it's reading memory from that. We'll watch it run. It's a little bit nicer like that. You can read the code later if you really like, which you'll like. Search process harness, and I think I need to provide the PID 1480, wasn't it? 1480. All right, so there it goes, searching through that. And the fact that some of these data structures returned not zero meant that it worked and it found things, and that was sort of my indication that I got enough code coverage in there with my data that I actually got some results out of it. Once that was working, now still with that data in memory, I can run the main Jack POS harness. We'll look at that. And so that's got a lot more of these breakpoints here. I've got breakpoints for patching command and control, install checks, blocking the shell execute, opening the URL so I can see what URL it's pulling, all that sort of stuff. And so basically we're launching the process, we're setting all our breakpoints. We modify the command and control from that I am not in any way redacting to my local VM here. It tests to see if the command and control's up, and it's up, it responds correctly, it's checking in. So right now, while that's searching, I can go back over to Jack POS here, and now I've got a bot checking in. And it's in this IP address range. It thinks that's in Zaire. I don't know how to build that country code schema up. 10? All right. I can bring that, the country code database in here. It's got some geolocation capability. Huh? South Africa. Yeah, I know that's South Africa. Oh, yeah, that's South Africa. Yeah, you're right. This is like just the default here because I didn't build that table out. IP address, MAC address for that VM, not for my host. And by now, we should have some dumps in there. Nope, not yet. It's still searching. It hasn't hit 1480 yet. This is the exciting part, y'all. The part where we wait. Should have killed some stuff. All right. Process Explorer still over here, showing us that we've got this Python. This is our Python running the malware right over here. We've hit 1480, so now over here we should have some dumps. Oh, no. What happened? It broke. Oh, but it hasn't checked in yet. That's what it is. Aha, see, there. That's where it sends it. So now it loops back around to the check-in, tests to see if it's up, and then it base64 encodes everything and sends it along. So now, dumps. So there, you can play around with this and you can have some fun with it. If you were really evil, you could actually just patch this malware and start using it for yourself. Don't do that. Naughty. Don't hack things. All right, so wrapping up on this. The idea is we're addressing reproducibility and verifiability in malware. So that's the preaching to the choir part. You know, we all want to have better information about what we're analyzing, and I encourage you to slow down for a moment and just document what you're doing and then share that. Giving the malware what it wants, the data it wants, the network services it wants to connect to, that's a big deal. And that's better than just a generic sandbox. It's not what you want to roll out for everything. You still want that generic sandbox as triage, but if you're really going to go deep dive and try to beat FireEye to that great new analysis and you want to be the cool one, you're going to do this. And then there's a potential for publishing this. It'd be neat to have a cloud-based service where you could log in and interact with these sorts of things in a relatively safe environment. So there's my contact information, Wesley at McGrewSecurity.com. I check that email wherever. There's a work email, but I only check that at work. There's my primary Twitter account, McGrew Security, and the secondary one, which is not listed right now, I hunt pineapples. So I'll be hanging around the con and talking to people and answering questions and drinking and things like that. So get up with me. Thank you so much for coming.